A new episode of Last Week Tonight features coverage of 3 of the crypto industry's most recent disasters.
There is Terra, a cryptocurrency, Celsius, a crypto bank, and FTX, a crypto trading platform. In theory, they were supposed to be our next dollar, our next Bank of America, and our next stock exchange.
While the accusations against these entities of unsound business practices do make for damning cases, the show's host, along with many other talking heads out there, try to make it sound as though the kinds of practices that led to these disasters are somehow unique to the cryptocurrency space. Is this true? Let's examine Oliver's claims. He starts with the collapse of the Terra Luna system, wherein people who bought the supposed stablecoin Terra USD took on major losses when said system failed to keep its intended peg to the US dollar. The peg was lost, as Oliver correctly explains, because Luna coins, the underlying asset meant to maintain the peg, were never suitable for the job to begin with. But doesn't this scheme, that is, backing a supposedly stable asset with an entirely unsuitable one, remind us of something else in recent history?
Mortgage bonds are dog shit. CDOs are dog shit wrapped in cat shit.
Yeah, that's right.
Wasn't the 2008 financial crisis precipitated by the very thing that Oliver accuses the Terra Luna system of? That is, the massive sale of supposedly stable assets, in this case US securities, that turn out to be backed by wholly unsuitable ones, in this case subprime mortgages? The telling difference between these two cases is that the major sellers of subprime mortgage-backed securities were bailed out by the US government in conjunction with the Federal Reserve, and walk free today, while the major seller of Terra Luna tokens, Do Kwon, received no such bailout, is currently being held by police, and may go to prison. Now to Oliver's second point, Celsius, the crypto bank and lender that filed for bankruptcy and declared itself unable to pay back billions in customer deposits. Banks not having enough cash on hand to cover withdrawals. Now, where have we heard that story before? Oh yes, just last week. And a handful of weeks before that. And shortly before that, too. The main difference in this case is that legacy banks have something that crypto banks do not. That is, a relationship with the Federal Deposit Insurance Corporation, or FDIC. In each of the recent legacy bank failures, the FDIC, funded either indirectly through bank user fees or directly via loans from the federal government, has promised to make depositors whole again. Now that sounds pretty good though, right? That's a point in which the legacy system is definitely more trustworthy than the one run by crypto cowboys, right? Consider that the current coverage offered by the FDIC is $250,000 per account. But when the FDIC was first created in 1933, that amount was only $2,500. Now, looking at those numbers, which is more likely? That for some unknown reason, bank users currently demand literally 100 times more insurance than they did only 90 years ago? Or that the US dollar has lost nearly 100% of its purchasing power over that same time period. The FDIC may well have been key in keeping the legacy banking industry alive for as long as it has, but it has come at the near total devaluation of the asset it maintains. Not really something to brag about. Now finally, crypto exchange FTX. The primary accusation here is that the entity, run by Sam Bankman-Fried, or SBF for short, also filed for bankruptcy and also declared itself unable to pay back billions in customer deposits. Now, SBF was a darling among members of the federal government, making massive donations to the Biden campaign, being invited to speak at White House and congressional committee meetings, and even having multiple private chats with the head of the SEC, Gary Gensler. This extreme popularity, combined with the eventual massive implosion of his operations, takes a page straight out of the book of none other than the infamous fiat scammer, Bernie Madoff.
The danger is regulation might give this sector more legitimacy. It'd make a risky investment look safe when it is clearly not. And that, in turn, might entice banks to start getting more involved in crypto, giving the sector even more legitimacy and also exposing all of us to its volatility.
If regulated fiat markets are so much more legitimate than the supposedly unregulated crypto ones, how could it be that Bernie Madoff and Sam Bankman-Fried were able to do essentially the same thing in each of them? All told, it appears that John Oliver isn't truthful in his claims that the crypto industry is somehow singularly and uniquely ripe for fraud and mismanagement when compared to the alternative. An examination of history suggests that the only real differences in crypto markets versus fiat ones is scale. That is, the crypto industry, currently in its infancy, suffers from a plethora of financial scandals, while the legacy financial industry, many more decades into its lifetime, suffers from even larger ones. Ideally, we'll create the education and tools to empower anyone who wants to avoid financial scandal wherever possible. With a backdrop of trustworthy money, accessible self-custody, and transparent exchanges, we just might have a chance. This is why we build.
Hi, welcome to Incubator Weekly. Quick question, can you hear me okay, AJ and Ryan?
Yep.
Excellent. Wonderful. Well, we are back this week with the third installment of the Dash Tools series. And today we're covering DashHD in particular. And in this case, the HD stands for Hierarchical Deterministic. So Ryan, will you give us a quick overview as to why another hierarchical deterministic tool is useful in the space?
Yeah, this is the continuation of the same theme that we've had for 2 weeks, basically. We wanted some lightweight tools that were standalone that could act as good learning resources, good educational resources, and more importantly, perform well in a browser setting and in other compilation target settings such as Webpack and Bun and things like that are coming up. So yeah, that AJ can probably give you a better description of the technicals of that, but that's basically why I think this is an important project and an important part in the series. And the HD part specifically, this is kind of the culmination of the last 2 weeks where the tools from Dash Phrase and Dash Keys are both used in this library to create a wallet that's very user-friendly and that can be backed up very easily. And yeah, we're going to learn more about HD paths and things like that. So let's jump right into, I think AJ can give us more of the technical description.
All right. Well, first of all, my friends, let's pop a top and open focus. Good old Mountain Dew will help us explain things better. 1 second. Sponsored? All right, now that I'm juiced, I can talk faster and take less time, right? No. So, the 12 words that are the wallet.
And let's zoom in if we can, AJ.
Oh, yes.
Thank you, dear.
There we go.
So the 12 words that are the wallet that we talked about with Dash Phrase goes through a technical term, key expansion. Basically, jumble it up and make it different in a secure way. And that results in our seed. So the 12 words turn into the seed, and the seed is actually what goes into the HD wallet. So we kind of resume from that point. And HD means hierarchically deterministic, but I also think that it ends up being a really nice term because HD, we think of things that are lossless or near lossless, and non-HD, we think of things that are lossy. So, if you watch a standard definition movie on your HD TV, it looks like crap. And if you watch an HD movie on your HD TV, it looks pretty crisp. And the DashHD is basically, if you have those 12 words are lossless. You know, you print them out, you send them to a friend, well, not a friend, but someone that a legacy contact, I think is the appropriate term. You know, you send them to a legacy contact, you do whatever. You keep those 12 words safe, not in the sense of safe from bad guys, although you need to do that too, but safe is in the sense that you can use it to recover your wallet. So that's where the seed phrase comes from. And then this seed phrase is kind of hashed with, well, it's a kind of a, I don't know what the right term would be, but there's an HD path is what it's called. And the HD path, this is defined by the BIP, 32 and BIP 44 specs. Yeah. So it is the address of your address. So this right here is what the software uses underneath in combination with this to produce keys that are safe to share with other people. Basically, this is what allows you to have contacts. And that refers to the Evo system as well. So when people talk about Evo and having contacts, the way that you have a contact is by taking your seed, mixing it up in a certain way with an HD path, and then getting out an XPUB that you share with that contact. And you share it typically in the form of a QR code, but the QR code is just just the blocks that represent this same data. So this is the text version, but if we wanted to show what you share with somebody else, it'd be the QR version. And you can also embed this in a link and share it that way, or send it in a message that encapsulated in a way that the person doesn't necessarily see all of the text. But that's the essence of it, is that it walks down this path. It basically splits the path by the slashes here. And you'll notice there are some parts of the path that have an apostrophe. These are parts where you would not share even the public key with someone else. And then you have the parts that don't have an apostrophe, which would be the parts that you do share the public key with someone else. So they are known as I'm trying to think of the technical terms. I can't remember it off the top of my head, but it's essentially whether that entire segment will produce something that's considered to be private as a whole, even the public part, or public, meaning that the public part can be shared not with the world, generally speaking, but with a specific contact. So go ahead.
Okay, can I back up and just recap a little bit here?
Yes.
So the HD, hierarchical deterministic. The deterministic part is basically saying that when you have a seed, which is that AC27 number up above, when you have a seed, and remind me how many bits that is.
It's 256 bits.
Okay, so it's a 256-bit number. And it's basically saying if you have this random seed, 256-bit number, and the whole premise behind this is we don't want address reuse. So we want to be able to create multiple addresses, but we only want to have one seed. And so the hierarchy part is that instead of just creating, you could add some bit of randomness to create multiple addresses from this single seed in a deterministic way. But you also want that to be hierarchical, meaning it's organized in a certain way. And I think that's what these slashes mean, right?
Yeah.
The slashes kind of define the hierarchy. And the definition of the hierarchy is in that that BIP that you referenced before. So that's just the kind of the high level. But I also wanted to point out that when your HD key path, X key path, is a certain length, so you have the M44500, that results in what you're calling XPRIVs and XPUBs, and they have these prefixes of XPRV and XPUB. But when you extend that path, it's different. Now it's creating WIFs and addresses, which we talked about last week. So
Yeah.
Are those the only two path lengths that matter? Or could you have a shorter path that's just the M4450 part without the second zero? Or are these the only two types of key pairs that you get?
So according to BIP 32, it's completely arbitrary. BIP 32 does not specify any real structure. It just says thing's going to start with M and it's going to have a slash, and there's going to be parts that are designated as purely private and parts that are designated as partially public. But it does not define any structure in terms of what the numbers mean or how long it is. So in practice, we use BIP 44, and BIP 44 defines that when it has 1, 2, 3, 4 components, because the M doesn't really count, then that is an XPUB path. And when it has 1, 2, 3, 4, 5 components, that is a WIF address path. So those are the only two that are useful, as far as I'm aware, in any... Well, then currently these aren't useful either, because currently no software actually uses these. They're a spec that's defined. I think it's a glorious spec. I think it's something that actually was well thought out, well reasoned, and there are some bits about it from the technical implementation. I think they did a little bit of Rube Goldberging, but throw that in the noise it's hashing anyway. This is a good specification. And I think that for the same reason that a lot of the Bitcoin specifications didn't take, mainly that people who understood that they were valuable and useful wanted to make sure that they didn't, I think that this hasn't really taken either. But the potential for this has been there, and there are one or two wallets that support it. And at the core, the -iOS wallet does support this for your main wallet, but not in the sense of contacts. So contacts, okay, so this has been widely deployed for main accounts. This has not been deployed for contacts, which is what it was intended for.
Yeah. Okay, I just wanted to point out a couple things. So the first thing that you mentioned is this is defined by BIP 44. That's what that 44 means in that XD right after the M. That's what the 44 means. The next number means dash. So when the Bitcoin creators were not maximalists, they actually wanted to support other coin types, and that's what that 5 is. And that just gives you an idea of how mature the Dash project is. We got the number 5 in this list, and I believe 0 is testnet for all the coins, and number 1 is Bitcoin, and then number 2 and 3 and 4. I don't know exactly what those are, but I think 2 of those are kind of like not even currently interesting projects anymore. We don't have to look it up. But yeah, just gives you an idea of how mature the Dash project is. We're number 5 on this list. And then the other thing I wanted to ask you, AJ, is when you're looking at this string, this M44500 string, is that actually in the code? Are you actually using that as a string, to use a coding term? Are you using it as a string to hash the seed with, like literally just concatenating these strings or something like that? Or how is this path actually used in the code?
So it's hierarchical. So the M is ignored. The M is just kind of to say this is an HD path. And then the 44 is actually used as an integer, but the apostrophe is used as a flag, because there's basically 2 code paths where it says derive this from the previous private key. So there is I guess the M stands for the master key, which is derived from the seed. So the seed isn't used directly, but the seed has a one-off algorithm that's very similar to the others, but slightly different, because this is, well, the seed. So it generates the master key from the seed, and then in the next path, it it uses the 44 to do part of the hashing, but it uses the tick mark to designate that this is a purely private hash. And so it uses the previous private key rather than using the previous public key. And then it generates a new private key and a new public key. And there's a variety of components to this that are internal mechanisms for how this thing carries forward. And some of them are embedded into these. And so these are kind of a sum of the state. This isn't a single value, but this is actually multiple values in a specific order so that it constructs the state of the hash system. And every time you go one layer down, it's a new
Algorithm.
it's not a new algorithm, but it's a completely new key. So it's the same algorithm, other than the very first one is tweaked slightly because there is no previous private key. It's working on the seed, so it has to convert the seed to a private key and then use that. But as you go down, so it's BIP 44, and then 5 is dash, and then 0 is the account, and then the next 0 is the usage. Now, an account would also be a contact. So we would have some other mapping that's like 15 is John, or 17 is @Rion, or 258 is so-and-so at example.com. So we'd have some other mapping layer, and Evo is putting that mapping layer in a, not a blockchain, but a persistent database. Maybe it is technically a blockchain. I'm not sure. I don't remember exactly what the spec is, but Evo is doing this too, and they put the mapping layer down there. It also makes a lot of sense to just have that mapping layer in the software that you use and have it sync between the devices. But anyway, so you've got this, but then when you go sideways, it's different. And the only place that it really makes sense to talk about going sideways for the purpose of this discussion is you go from 0 to 1 to 2 to 3 to 4 to 5 to 6 to 7. Oh, sorry, not there. Here, the account, this one always stays 0. That's the usage. And the usage is always 0 for this type of key. It's we could potentially use it for mixing to denote 0 is unmixed, 1 is mixed once, and so forth. But that's something that's been talked about, and I think is a really great idea. But for the purpose of this discussion right now, this is the account is the one that increments. So we can have account 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever, up to 2 billion. And then as you go sideways on, so this produces different keys that all come from the same private key. We don't really use those. We use it down at this layer. This layer gives us one layer of separation from the origin private key. And some people say that if you get enough private keys that are derived from a public key, that it makes it possible to derive that public key. I would love someone who understands that better to explain it to me. As far as I could tell in the code when I was looking at it, I did not see how that would be the case. But it may be I may have missed something, or I may not have understood the mathematical concepts behind it well enough. But in any case, once we have the account generated, so we generate many accounts, then we generate the usage, which for all intents and purposes is always 0, at least in the contact scenario. And then we generate the address that would be the contact, once they've received this public key, would generate addresses. So basically in their software would keep track of the indexes of, hey, this address 0 has already been used, and then increment to address 1. This address 1 has already been used, increment to address 2. Address 2 hasn't been used yet. And all of those are related in a sense to the key that's being used as the private key that came from this iteration. So whatever the child iteration is, there is a tweak to the private key of its parent that generates that child key. So, and this is the magic that allows you to have an XPUB that you can share with someone, is that the tweaking of the private key and the public key happen in step, such that without knowing the private key, only knowing the public key, you can know that if you perform this mathematical operation on the private key, you can know what mathematical operation was performed on the public key, and therefore you can perform that mathematical operation on the public key independent of the private key.
All right.
Okay. AJ, TL wants to know, is the XPUB key what you give to a, quote, contact, so they can generate addresses to send Dash to you and get new keys every time?
Yeah, exactly. So the XPUB, the software will, you'll click create contact, and the software will create a path and map it to that contact in some way. And then that path will derive once, twice, 3 times, 4 times, and that gives you this XPUB. And then that XPUB encodes some of the information in it so that it doesn't need, the next time it actually doesn't need any of the other parts of the path. The only part of the path that it will know is its parent. It won't actually know that it's a dash address. It won't actually know that it's derived from BIP 44. It won't know anything about it except its direct parent. It'll know that its direct parent was 0, and it will also know the depth that it's at. So it'll know that it is a depth 5 key. And so at that layer, the contact software would have to know that this is supposed to be for Dash because the information about Dash isn't encoded in it. But from there, it can take that XPUB and then it can just generate 0, then generate 1, then generate 2. Just basically take that same key information, run it through the hashing algorithm as many times with a new number. And I do want to just point out one thing here. For anybody that's not aware, it would seem really ridiculous. Like, okay, if I know that there's this mathematical operation and it's done with the number 1, well, I could really easily guess that the next number is going to be 2. So wouldn't I know what the next key is going to be, even if I don't have all of the other pieces of information? And that answer would be no, because the way that hashing works, if you change a single bit of information, the output is changed in what appears to be a completely random way, which is why we use hashes for so many things related to security, because we can take a known value and produce a value that is not reversible. So you can know which value is going to come forward, but you can't tell what value it came from backwards.
Okay. I think that we should scroll through this README to see a little bit more of what documentation you have so that people can know what this repository can do for them.
Okay. So the first part here is just showing you what this stuff looks like. So if you know what you're looking for and you see these things, you're like, ah, yes, this is the thing that I'm looking for. It also has examples, again, that are from the Zoomonic and the Catmonic, which are 12 words that were part of the original, 2 sets of 12 words that were part of the original test spec, so that when you're developing against them, you can run the same tests that were run by Trezor and get the same results. And so all of the examples are based off of basically well-known test values. And those first ones I showed you are actually well-known. Well, they're not well-known test values because the Trezor suite doesn't cover what they look like for Dash, but other than that, they are well-known test values. So this is library documentation, and it's kind of this, this has been criticized, but I don't really know a better way. If somebody knows a better way, then by all means, open up a PR and help me. But it's the same information 3 different times. The first time is like, okay, I've done this before. I'm familiar with this in another library. I just need to know what this library looks like and calls it. And that's what this first 1, 2, 3, 4, 5, 6 is it's like, you already know what you're doing. You've done this before. Boom. There's your quick overview where you can copy and paste. If you're familiar with HD keys, this should be pretty familiar to you and it should make sense. Then the next one is, okay, if you're not that familiar and you need a little bit more of a refresher, it's the same thing, but it includes more of the steps, like the predecessor step to get the seed. It also includes a little bit about error handling, because if you're familiar with HD keys, then you would know that they can throw errors because sometimes a particular number happens to go into a space that can't be used as a public key. So we've talked before about how a private key is any number that can produce a public key. There are a small set of numbers that, for various reasons, usually either that they reach infinity or they go beyond the curve, they cannot produce a public key. And I don't know if you can know ahead of time what those numbers are because of the way the hashing process works. I don't think that you can. So you actually need to do some, or you should do some error checking. In all likelihood, one customer will never have an error because the idea that they'd have a random number generated that happens to fall in the invalid range is vanishingly small. But across a near infinite number of customers with a near infinite number of transactions, eventually there will be an error that is not, it's an error in the sense that it's a mathematical impossibility, but you can just kind of skip that key or account or whatever it is and go on to the next one. So this one includes some of that error handling example in here as well. So, you know, if you try to derive an address and it fails, there should actually be some error handling on the error to make sure it's the right type of error. But anyway, yeah, just skip to the next one and continue. If you try that 3 times in a row, something else is wrong. The API has the from seed, from X key, from WIF, from adder, from XPRIV, from XPUB, derive path, derive child. So it's some convenience methods here. Again, we talk about the importance of being able to test if something is going to be valid. And then so there was basically 3 different ways that we did that one thing, and then we're down into, I think, is this the glossary here? I think, yeah, this is basically the glossary. No, this is the top level exports of the API itself. Okay, so we're past examples and we're into just top level exports. Again, this is more for when you're trying to figure out what magic numbers mean. It's just really hard to find that information out sometimes. So I try to put it all in the README. So if you do a Command F, a lot of this isn't necessarily meant to be read as much as it's meant to be searchable. So that if you hit Command F or Control F and type something in, it'll take you to the part that explains that thing. And you've got references for the different functions and what the inputs and outputs look like and all that stuff. I mean, it takes a big brain to get this stuff, or at least a lot of time. It's you have to expand your brain in order to fit all this in there. It's not simple. It is convoluted by design in kind of a good way, but it means that, yeah, it's difficult to grok this stuff. It's difficult to understand it. So there's a lot of examples and whatnot.
So what I like about this documentation is that for all the JavaScript haters in the world, which there's a lot of them, including a lot of JavaScript haters on our own Dash team, this is a good way if you don't have any idea what this is all about, but you are a very good programmer in a specific language that's not JavaScript. You could look at this and know exactly how to port this over to a different language, right?
Yeah.
Sufficient documentation for you in one place to be able to port this over to, say, something like Python or Rust or Go or Zig or whatever.
Yeah, the beauty of this, let me get back up to the top. I do want to show just a little bit of the code just to kind of give that perspective. But the beauty of this is that it's written in JavaScript the way that an absolute retard would write JavaScript. And there's no classes, there's no polymorphism, inheritance. I mean, basically all the computer sciencey words that every language tries to capture a little bit differently, there's none of that in here. It's functions and it's objects.
And when you say retard, I just want to make sure everybody knows what you mean by that, because
sure,
I know you well enough to know that you're talking about, like, there's that meme with the bell curve where on the left side of the bell curve there's the really dumb brain guy, and he does a thing in a certain way, and then once you get to the middle of the bell curve, like your average intelligent person, it's this very complicated thing, and then once you get to the other side of the bell curve, the very, you're looking it up, I hope, the very intelligent person basically goes back to the way that the dumb person does it, which is really should be the right way to do it.
Yeah. So this is it. So there's the whoops, what happened? Something happened. There we go. Okay, there we go. Let's see if this one will open up. All right, yeah. So you've got the caveman on the one side, and then you've got the average person, and then you've got the genius. And the idea is that the average person is going to add in a lot of complexity and try to make it seem really smart. But both the caveman and the caveman, usually the caption is, "I'm dumb and have no idea what I'm doing, so I do it this way." And then the genius is something like, "I realize that I'm really dumb, and to compensate for it, I'm going to do it this way." So it's, yeah. And often in the meme, there's like one slight variation between the caveman and the genius, and the it's like, in JavaScript, it's usually an error check or something like that when they show JavaScript examples of that meme. But yeah.
But the idea is that you're bringing it back to like fundamentals.
Yes.
In a very understandable, approachable way.
I hope so. But I mean, one of the problems is that a lot of people are, if you come out of boot camp or something, you're so used to seeing all of the complexity in the classes. When you don't see it, sometimes it's a little jarring because you're like looking for it, but then it's not there. So there could be that. And, I'm open to criticism. If somebody has a better way to organize the code, by all means do it. But I think it's a heck of a lot better than what I had encountered when I came here. Two more things. So there's this walkthrough, and this is if you're really not familiar with this and you'd like to understand it in a succinct, like I don't speak succinct, but I tried to write the documentation succinct. So if you wanted to go through this, the walkthrough is you're not familiar with this and you'd like to go through step by step, copy and paste code, see how it works, understand with, more comments, more explanation, but still trying to be very succinct. No paragraphs, just individual sentences. And this is what the whole thing looks like. And then there's the glossary, and the glossary is, again, more for the Command F ability of being able to go through and say, okay, what the heck does the term HDX key mean? What does HD path mean? And then, again, single sentences, and then single lines of code where possible, no paragraphs. Everything is just single sentence. Anyway, so there's that. And then the code. A bunch of type information for tools, and then everything is basically just an object with functions for all of the utility functions, and the same thing for the main functions. It's all just object with functions, object that contains functions, calling on an object. So a very almost, I don't know what a Zig style. I would say C style, because C is a very function-oriented programming language. You don't really have objects, but then not having any name spacing at all is really, really bad and very difficult to work around. So it's got that benefit of everything is just a function that accepts an object, and the objects, as much as possible, are very, very simple objects that just have keys and values in them, or are values like the integer or the buffer or whatever. So the functions.
I think I'll start calling you Dewey, AJ.
Dewey?
Yeah, like Dewey Decimal System. I don't know, a person who organizes libraries, composes and organizes libraries.
I see.
Dewey.
I see.
Yes.
Anyway, so here, hopefully you can kind of see that most of these functions fit in a single screen, and I tried to make naming consistent between this and the other libraries, and I also tried to make it so that the functions are the right size, because if you make things too small, then you have to spend all your time just going back and forth between functions to understand what anything does. But if you make them too big, then it's difficult to tell where the pieces are. And so I did my best to orient this in such a way that code that changes together stays together, and code that could be used independently is in its own function. And there are some very small abstractions that we could potentially deem useless abstractions, meaning that the abstraction adds more complexity than it adds value. So there's, this is a very, very tiny abstraction, but There's a reason that I did it when I did it, and it's often for naming conventions or consistency or something like that. So I tried my best. I feel like this is a heck of a lot better than what there was before.
Well, here's a question of how potentially it could be even better. AJ ONeal wants to know, BIP44 HD wallets seem like a great path forward, but the setup between users seems like unnecessary overhead. Do you think that perhaps there may be a way that HD paths could work without contact setup?
Well, I need more information to understand from your point of view what you're saying, because my headspace and your headspace are probably different. So let me read this again.
And I will, while you're reading that, I'll give my stab at this answer.
Okay.
And also introduce next week or next show. I don't know if it's going to be next week, but next show, we have another library, Dewey Decimal Guy, that is a wallet, and the wallet is supposed to make that contact creation very simple, and just with the caveat that this is not the same as Dash Core Group's contacting system. This is basically just exchanging XPUBs. And we do have a wallet library that's supposed to make that very simple. So yes, it could be complex to do this contact setup. It might seem like that, but that's why we've created another library for that.
And I'll add to that, I think the minimum complexity, and again, we have to be practical. We have to think about the real world, not about Edward Snowden. Yes, Edward Snowden exists. Yes, you're not Edward Snowden, though. You might feel like you're Edward Snowden, and you might want to follow the same practices as Edward Snowden, and that's up to you as an individual to kind of navigate that. And we shouldn't make it hard for someone to behave in the manner of Edward Snowden if that's what, gives them a sense of purpose in their life. But the average person's not Edward Snowden, and we're not trying to protect from those types of things. The most important thing is that we have relationships with other people that we exchange with, and that we can reliably count on those. So the simplest method would be literally to take a screenshot of the QR code and send it via text message, just like you do with Venmo. I think that is the level that we need to start from, and we can add more onto that. Also, I envision a world, and Ryan kind of turned me on to this idea, but I envision a world where we have 4,000 servers that sit and do nothing useful almost, right? They run a couple of hashes every few minutes. They're doing almost nothing. What if we could take those 4,000 servers and make them of more use to the network? What if we could have services that run on them where you do store some of your information encrypted on them, and you pay for that, and in a like, let's say, a monthly way or a yearly way or whatever. And what you would have to do in this scenario is you would have to basically pick 3 services at random, pay each of them whatever the fee is, and then publish your information to them and keep a local storage of which servers you had picked, or have some mechanism to quickly query among the 4,000 servers which ones have your information. And then if one of those servers disappears, your software would periodically just need to query to find out, hey, is my stuff still where I think it is? And then be able to pay another server, and I'm imagining this fees would be very small, like 50 cents per year or something, and if you pardon my fiat. But you can just publish multiple copies of something to a couple of places and have a really, 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 really high probability that it's going to be there forever. You don't need a perfect probability. And if you feel like your data is more valuable, your contact information is more valuable, then pay $2 a year and store it on 4 or 5 or 6 or whatever. If you feel like you need 100 copies, just pay for 100 copies.
And right now, what we have, like what DCG is building, is the default is just going to be, you can store whatever you want to store. It's going to be stored on every single server. And it's a longer discussion we won't get into today about how we might improve that and make it, first of all, more affordable, because you're not storing on 4,000, you're storing on 4 or 10 or whatever. That's a totally different discussion, but worth having, because we do want to have those fees a little bit lower, and it does seem a little excessive on the Snowden side that we're going to be storing that data on 4,000 servers for time and all eternity. So that may
when I'm dead, I don't really care about my contacts anymore. You know what I'm saying? If I stop paying, it's because I'm dead, and if I'm dead, then you don't need to store my data.
Right, and even the solution that we're going for with Dash Platform Evolution, it will allow people to remove that storage and get refunded for a portion of what you paid originally. So that is a good part of the design system that we've already got with Evolution. I think we have one more question, and we should probably wrap up. Will find market for such storage? Will we find a market for such storage? Yeah, that's the question. I'm not sure, but I think that there's a market for. There definitely is a market. The only question is what size that market is, and this is going to kind of be if you build it, they will come. If you build it, they might come. Who knows? But we're going to build. We're building it one way or the other.
I'm going to say that. I mean, I don't know whether that question was directed towards the Evo scenario or the scenario that I outlined. I'm going to say with the scenario I outlined, we know there's a market for that because that's the way the market currently works, right? You look at something like, let's take S3, and I don't necessarily think that S3 is the bee's knees, but as a protocol, I would say that S3 is one of the smarter things that's happened. The storage backing for something like S3, if you want to look this up, there's things like Ceph FS. That's basically there's 3 copies of any item, and so you're paying for that. The reason that S3 is so expensive is because you're paying for 3 copies of the thing, right? So there's already the technology for this already exists. The market for this already exists. It's already been proven. Is there a competitive advantage? Probably not, except for people who are Dash users. There's probably a competitive advantage there. So if we have Dash users, then yes, we'll have people that want to spend Dash to be able to have similar storage that is in some ways more censorship resistant.
Okay. Well, that was an interesting topic to end on, and I know that we'll talk more about that in the future. And as Ryan said, next week we will either be covering more of Dash tools or potentially talking more specifically about the application of these Dash tools, which in this case is for the Incubator specific developed wallet that we covered some 5-6 weeks ago. So that will be fun. We look forward to seeing you then. And until that time, take care.
Bye, everyone.
Adios.